good afternoon, good evening, good morning, wherever it is you're watching this from. So basically, the sum that I'm going to be explaining today is called number of islands. It is a classic problem that are present in most of the C sheets of DSA, like Neetcode, Striver, etc. So let us read the problem. Given is an m cross n 2D binary grid which represents map of 1's land and 2's water. That means the 1 in the map represents land and 0 represents water. We have to return the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are surrounded by water. So this is example number 1. This is example number 2. So let me show you the example. Basically, I have drawn this here, the example number 1, and this is the example number 2. Coming to the example number 1, basically what they're asking us to do is we have to count the number of islands. So what they've said, an island is the ones that are connected to each other, right? So like this is connected to this, is connected to this, is connected to this, is connected to this, all these are connected. So basically this forms one island, right? So वो लोग ने क्या बोला कि whatever is horizontally and vertically, this is how you form an island. We do not go diagonally. That means if there was a 1 here, then this one would not be a part of this island. You can see here all of these are connected either horizontally or vertically. All these are connected vertically and this is connected horizontally. These are connected horizontally. These are connected horizontally. But this is connected to this diagonally. That means this is not a part of this island, and you can say that this is a totally different island because it is connected to nobody horizontally or vertically. So like यहाँ पे इसके कोई island नहीं है, right? So yeah, so how are we gonna solve this problem? Basically this is an island here. So here if you see, this is straightforward कि हाँ, the answer for here would be 1 because there is no other island that is connected to this, right? This was our example, and yeah, so here our answer is 1. What about the second example? Here if we see, we take this is connected to this is connected to this is connected to this. So like this is one island, then where is another one? Here is another one. Is this connected to anything vertically or horizontally? No. If you see here, 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 not this one, sorry, vertically and horizontally, there is no one. That means this is another standalone island, this is another standalone island, 1, 2, and then we have ones here. These are connected horizontally. Are these connected anywhere else? Vertically? No. Horizontally? No. Diagonally? Yes. But in our given problem, we have been told that we just have to consider horizontally or vertically, right? So how do we approach this problem? So basically to count the answer here, 1, 2, 3. Our answer here is 3. Our answer here is 1. So how do we approach this problem? Basically this is a graph. We treat this as a graph, and we have to do, whenever you hear the word graph, anytime you hear the word graph, 3 things should come to your mind. First, that is 1 is BFS, second is DFS, and third is union find. These are more widely used 3 techniques for graph solving, right? So how do we approach this? So basically we start at 1 a 1, we start at a 1, then we see its neighbors like horizontally and vertically. Does it have a neighbor? Yes, it has. Then we check this. Does it have a neighbor? Yes. Does it have a neighbor? Yes. We check this. Then we check this. Does it have a neighbor? Yes. Does this have a neighbor? Yes. Yes. So what are we doing? Basically we are checking level by level, right? So we first checked this, then we checked this, then we checked all its neighbors, then we checked all its neighbors, then we checked all its neighbors. So basically we are solving this via BFS, that is breadth first search. You can also do depth first search for this, but the approach that I am going to be using is breadth first search. So I hope you all understood the approach, but how are we gonna solve this? Basically, what would our code look like? Because at the end, we just have to code it out, right? So first, basically, we have to start traversing the graph. Okay? We have to start traversing the graph. So how do we traverse a graph? For I from 0 to number of rows, right? From I, then number of rows. For j, 0 to number of columns, number of calls. Now if you see, we have to find the number of, we have to find a 1, because if there is a 0, there is no point getting a 0 because it is water. We need to count the island, that is land. So we would see that if our grid at the given position is equal to 1, then we would do something. We would carry out our BFS, that something is BFS, right? So this is how we do this, but there is a catch here. How do we go about our BFS? Okay. So basically, if you're seeing this, first we visit this. Okay. We obviously here would need a visited array to keep a track of what all we have visited, so that whenever we go through this, the grid, so like if we have already visited this as a neighbor, there is no need of visiting it here again, no need of counting it here again, because it would be visited in the BFS. So basically we start from here, we go to its neighbors, we visit the neighbors, both its neighbors, then we visit both its neighbors, then we take any one, visit both its neighbors, then we take the other one, visit both its neighbors. This was already visited from here, so we do not visit this, we just visit here, then we visit its neighbors, then we visit its neighbors. Basically that is how we are gonna do this. So it is basic BFS. So we will need a visited array. So let's just assume that we have created a visited array, and we need our visited at I comma j to be false. Let's just make it boolean so that we have not visited that, right? So now if you see, what are we doing here? If you see the crux, whenever we start, so let's say we start with ij, firstly we'll find this, right? So we find this, we start visiting in the BFS function that we're gonna call here. In the BFS we will start visiting, right? So we're going to start visiting. So since we're going to start visiting iska neighbors, here neighbor, we visited these, right? So then we go here, we visited these, then we go here, we visited. So basically we visit all of the neighbors, all these neighbors we are gonna visit inside the BFS function, right? So can you see every time that, can you visualize that every time we are gonna go inside this grid, every time we go inside this grid, we're gonna visit a new island, right? So let's take this example. uh, Firstly we find this, we visit neighbors, visit, visit, then we visit neighbors, visit, already visited, so we don't visit. So this BFS would end here, right? This would end here, and this would end here, and we're gonna, when we traverse this like here, this would end and this function would return here. So all these would be visited. This visited I comma j would have all of this marked as visited, right? So now, so whenever it comes here at this wala, if this loop comes here, it is gonna be visited as true, so it won't go here. So every time this goes inside, so every time this condition is truthy, this condition is truthy, we're gonna be visiting a new island. I hope that was clear. So every time we come inside this grid, we're gonna add our answer with 1 because we are visiting, and then we call our BFS. ठीक है? So now this would be our main function, main, and at the end we're gonna return answer, obviously, because return नहीं करेंगे तो क्या होगा. Anyways, so that is happening. So I hope this part was understood. Now how do we go about our BFS? How do we go about our BFS, right? So our BFS is pretty simple. BFS में सबसे पहले we'll be needing a queue, because obviously in a BFS we need a queue, and queue में we're gonna put a pair, that is I comma j, because how are we gonna track which all neighbors do we have, right? And why did we choose a queue for BFS? Firstly, that is a basic BFS concept ki in a BFS you need a queue, because let's say I visit this node, this is a node which I visit, and there are 2 neighbors inside of it. So 1, 2, these are 2 neighbors. So let's say iska I comma j and iska x comma y, right? So both of these neighbors would have their own coordinates which are offered into the queue or enqueued into the queue. So we enqueue them and then we dequeue them one by one, so that we visit them first, because queue is first in first out FIFO data structure, right? So essentially whatever node we're gonna be visiting, its neighbors would be offered inside of the queue, and while we're traversing, while we're calculating our visited, we would be popping it from the queue, that we're gonna be dequeuing it from the queue and getting it out, and then visiting its own neighbors, right? So we'll be needing a queue essentially. So we'll need a queue which will store a pair matlab coordinate, we can say coordinate, we can say pair, right? So we can say coordinate, and we'll be defining this queue. Basically we defined the queue. Then the first thing we're going to do is we're going to do queue dot offer meaning enqueue. We offer a pair, that is we offer that coordinate I comma j, which was where we started the BFS, right? We went inside the BFS, we're going to offer this because we're starting with here, and then we're going to mark it as visited at I comma j is equal to true. Okay, visited at I comma j equal to true. So yeah, we're gonna be visiting it as true because we're gonna start with it, right? So now basically while our queue is not empty, we're gonna be getting our x and y from the pair, that is these will be our coordinates that we are gonna be popping it from the queue, that is dq or poll in Java. We are gonna be polling it from the queue, popping it from the queue, we get our quads. Then what are we gonna do? Matlab, what were we doing essentially? Here, if you see, this was inside the queue, we took it out, we got its coordinates. Then what are we doing? We are visiting its neighbors. We are visiting the neighbors and adding the neighbors inside the queue. Okay, that is what we are gonna be doing here. So first we check left, then we check right, then we check top, and then we check bottom, right? So to make the code simple for you, we'll be checking everything individually, or at least that's how I find it simpler. You can run a loop with the direction plus minus, adding it and all, but basically I like to keep my code very simple. I'll comment it like this is the left, this is the right. So I'll write the case for the left, and then the right, top, bottom will be very similar. So case for the left is ki if, firstly what we're gonna do, we're gonna check ki the popped coordinates are within range, because obviously if they're going out of the grid, there is no point in there's no point in seeing, right? So yeah, we're gonna be checking if they are in range. So how do we check if they are in range? X should be greater, oh no, we're checking for left, right? We're seeing if the neighbor is in range, right? So if x, we're checking for left, if x minus 1 is greater than equal to 0, if x minus 1 is less than equal to number of rows, and y is greater than equal to 0, and y is less than, oh, not less than equal to, less than, sorry, my bad, less than number of columns. So this is where we check, this is our check ki our neighbor is within range or not. Then the main condition is we're checking, right? So in my grid, that x comma y should be, that x comma y should be equal to 1, right? That x comma y should be equal to 1 because we are not checking for water, and it should not be visited x minus 1 comma y. Okay, I made a mistake, this should be x minus 1 because we are checking for left hand side. So if all of these conditions are truthy, then we go inside. That means, let's say in an example if I'm taking, so if this is the x and y, x comma y 0 comma 0, then x minus 1 is here, right? So this would be out of range. So next we'll be checking right, so this is in range. So then basically if this was right, so for right the condition would be x plus 1. Okay, so I'm just writing for left. Yeah, so firstly what we're gonna do is we're gonna offer this q dot offer x minus 1 comma y, and we're gonna be marking it as visited x minus 1 comma y is equal to true. That is what we are gonna do. Why are we marking it as true? Because we're visiting this, right? From here we are visiting this. Now why are we enqueuing it? Why are we putting it in the queue? Why are we offering it to the queue? So that we can later in this loop, in this very loop, we can pop it and we can visit its neighbors. We're gonna visit its neighbors, right? So that is what we're gonna do. And basically the conditions would be same for right, top, bottom, and after all these, this same block of code, after writing it for right, top and bottom, we're gonna end the while, we're gonna end the function, and that's it. That is all. So that is how we're going to be counting, right? So if I do a dry run, okay, if I do a dry run on this, so this is my queue, this is my answer, okay. We would be initializing answer as 0. So yeah, so we start with this, okay, because here this would be entering this part, this, oh shoot, this is where this would be entering. So we start here, okay. Then what was the thing, what were we doing? We were entering the BFS function, we were queuing the coordinates, offering the coordinates, and then we're marking it as true, okay. So oh my bad, ज़्यादा scroll हो गया. So whatever I'm gonna be visiting, I'll be marking it with red, okay. So I marked this as visited, I offered it in the queue, okay. I offered it in the queue, then I check left, nothing, then I check left, nothing, then I check right में तो है, so right has a coordinate, so we also popped this, right? So we have a coordinate in the right, so we'll be marking 0.0, 1. Then we check, we also visited that, then we check down, then we check up भी कुछ नहीं है, then we check down तो है, we have a neighbor in down, so we add that neighbor, we visit that neighbor, oh my god, what am I doing, we visit that neighbor, right? Then we visited this, then we'll be completing all these conditions, then we'll be looping again, okay, yeah. Then we looped again, then since q is FIFO, we take this out, okay. Our answer was 1, my bad, we since we entered here, our answer would be 1. Then we loop, and now we are dequeuing this, we are at this position, we check left, this was already visited, we checked right, this was already visited, we check up, that was already visited, we check down, down was not visited and it is within limits also, so we visit that and we add it inside the queue, right? We add it inside the queue, then we add it inside the queue, we have checked up, down, left, right. Now we again loop, now we dequeue this, and since we dequeued that, we check, we dequeued this, so we check left, we check right, visited, left, nothing, up, visited, down, it is water. So basically that loop ends, and then we again loop it up, we dequeue this, no, I think this, yeah, this was done, we dequeue this, we check right, there is no land, we check left, the land was visited, we check up, the land was visited, we check down, there is water. So now essentially that queue is empty because we looped through all this, and that queue becomes empty when it goes to again loop. So since the loop was empty, our BFS was done, our answer right now is 1, okay. So where did we enter? We entered here, we checked all of this, now we check here, this was already visited, we do not go here, then we check this is land, this is water, visited land, water, then we have unvisited land. Since we have unvisited land, we again go BFS, but before we go into our BFS, we increment our answer as 1 because we found a new land, then we go inside the BFS, we enqueue it, then we check its, we enqueue it, we mark it as visited, then we dequeue it inside the loop, and then we check its neighbors. Left there is water, right there is water, top there is water, down there is also water. So now when the while loop goes again, when it goes back to the while condition, our queue is basically empty. So hence we again come back to the main function. Here our answer is now 2. Then we go ahead, we check this, this was water, 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 unvisited land, unvisited land. Now again we mark our answer as 3, we mark our answer as 3, we again call bfs, we again go here, we again put inside the loop, is we again put inside the loop, this was 0 1 2 3, 0 1 2 3. So we again put 3, oh sorry, 0 1 2 3, we again put 3 comma 3 inside the queue, then we dequeue it inside the loop, we mark it as visited, we mark it as visited, then we dequeue it, then we check its neighbors, its neighbors is right, left, top, bottom, nothing, but in right we do have, so we visit the right, we add it inside the queue, we add it inside the queue, and we check other neighbors, there were no neighbors other than this, so we again loop, since the queue was not empty, this was dequeued and its neighbors were checked, its neighbors were checked, this is a visited, this is water, there is nothing, there is nothing. So essentially this while loop, when it comes back to the while condition, our queue was empty, our queue was empty, so our queue was empty, then we again come back to the main function with our answer as 3 already, and then since we went inside here, we check here, this was visited land, and then we are done with traversing our entire grid, and we are done with this loop, and then we return our answer as 3. So that is how this entire thing works. And if I am to quickly code it up, for you, if I am to quickly code it up for you, सबसे पहले तो let me define the pair. Basically this is a syntax, you can Google it, use AI to show a syntax of the pair, because I'll quickly write this. So basically you will ask me why am I doing this, because if you see in the queue, if you remember in this queue we are adding coordinates. So in Java there is no way you can store a coordinate, because a queue can only take a single argument, we cannot map it to two things. So we would make this as a pair, and then we would be putting pairs inside, right? That is the coordinates. So coming back to the code, I will define the main function first. We have we first define the visited array, grid.length greater 0 dot length if somebody asks me what this is, grid.length is the number of rows, and grid.0.length is the number of columns. This is the number of rows, this is grid.length, and this is grid0.length, that is the number of columns. Then I initialize my answer as 0. Then we traverse the grid for int I is equal to 0, I is less than grid.length I plus plus. For int j is equal to 0, j is less than grid 0 dot length j plus plus. So our condition was if grid at I j is equal to a land and it is not visited. Then only we will add our answer and we would go inside our BFS function with I, j, visited array and our grid. And if that, essentially this is our entire main function. After coming out of this, we are just going to be returning our answer. So basically now the main thing that we're going to do is define our BFS function, which would be taking int I, int j, or for simplicity let's just put int r, int c. What did we have next? Visited, boolean visited, and we have our char grid. Right, so now what was the first thing that we're doing? Okay, the first thing that we're going to do is create a queue. How do we create a queue in Java? We create a queue pair is equal to new linked list. That is how we create a queue. Then we offer into the queue our pair. R comma c. Then we mark that as visited. R comma c is equal to true. Then we loop while q dot is empty, not while q is not empty. We take our pair p is equal to q dot poll. Then we get our x as p dot get x. That is what we defined here, the getter setters. Q dot get x int y is equal to p dot get y. Then we got our. Now what we're going to be doing is we're going to be checking for left. So if y minus 1 is greater than equal to 0 and grid at x y minus 1, oh sorry, my bad, y minus 1 is equal to 1 and not visited. We have not visited x comma y minus 1. Now somebody would ask, while explaining you entered all the constraints, and why just here this? Because basically if we're passing r comma c, it has to be in the constraints. And now since we're checking, we are not changing our r. Basically this is the r that has been is the x, and this is the y that is c. So now we are checking the neighbors, so we just check that one because others are still static. Okay, so we again offer this inside the queue, new pair x comma y minus 1, and visited at x comma y minus 1 is equal to true. We mark it as true. Now you can see magic. So we define this for right, we define this for write as y plus 1 should be less than uh, y plus 1 should be less than grid of 0 dot length, because it should be less than the number of columns, because we are checking right. So the yeah, so again grade 1 grade plus 1, again this should not be visited, then this should be this should be this. Now here basically we're just gonna do x minus 1, we're gonna do x minus 1 for down, x minus 1 for up. We're checking up, the x minus 1 is greater than 0, we're gonna be removing this x minus 1, and we're gonna be removing this. Again same thing here, x minus 1, this is again true. Then we will be doing same thing for, okay, this was right, okay, let me just remove this, this was right. Now I have same thing for, I'll be doing same thing for down. Better I should just paste this so that I can just change all the y to x. This was grid dot length instead of grid dot 0 dot length. Again here it should be x plus 1, again this should be x plus 1, this should be x plus 1 plus 1. So yeah, I think that's it. That is all. Let me first check if my test cases are passing. And q dot new pair, this variable cannot be what happened, Macha? What happened? Q dot offer new pair, q dot offer new pair. What is the issue? Oh, this was a classic Java issue. Only static variables can be used inside of the static thing. Then I've written resisted, and this is public. Now this should work. And again resisted. Oh, my dog visited. That's what happens. But when you're doing CP, this would cost you a submission, so make sure you're doing it right. Now we're submitted and our submission was accepted, and I hope you have understood how things are working. And yeah, that's it. Thank you so much.